Okay, so Module 8. Module 8 is all about 3D printing, and this is an optional extra credit module that if you would like to participate after getting done with modules 1 through 7, you are welcome to do so. This only adds to your grade if you choose not to do it, and it is a choice. Once you have 1 through 7 done, it will not hurt your grade in any way. Okay, so let's look at our learning plan to start off with to get an idea of what we're going to be doing. So first here in completing this module, you're going to be able to create an STL file. An STL file is a stereolithography file using your SolidWorks part model. And that's going to be a file format that is needed for 3D printers to actually, use and read. Okay. We can't use a SolidWorks part model to directly send to a 3D printer. We have to switch it to a different format, and that's going to be STL. And that is part of what SolidWorks is able to do. So I'm going to show you how to do that. And then through this process, whether it's tonight or on Thursday, depending on who is ready, I want you to experience seeing the 3D printer that we have, the 3D printers, I should say, that we have here on campus, and specifically in our lab up in our mechanical design area. We have some FDM printers up there, and I'll kind of share with you what that is. Now, I am going to be doing a lecture demo, just kind of showing you just kind of some features that you can add to your part. Now, the part that you decide to create, if you're participating to 3D print, the maximum size has to be 3 inches by 3 inches by 3 inches. So a 3 by 3 by 3 cube is what your model needs to fit into. Now, your model must have these dimensions already. I don't want to have to rescale anything. I don't want to have to go into your model. So if it's not, I won't print it. So if yours ends up being outside of that 3 by 3 by 3, and to the correct units, English units, if it's in some other units, well, millimeters, I guess would be the only other ones, then it just doesn't get printed. So those are going to be your responsibility going into getting me your files. Okay. So when you submit, you're going to be submitting 2 things for me: your SolidWorks part model, not a screenshot. Okay. The actual part model file. Okay. That's going to be one of them. And then the other one is going to be the STL file that you create from the part model. All right. And again, in the correct units and to the correct size. Otherwise, it won't be printed. All right. That's your responsibility coming in. All right, so let's talk about this process that we would go through and what FDM printers are. So what I'm going to do is I am going to just go to the Stratasys. There we go. 3D printers, additive manufacturing company, Stratasys. They make 3D printers, and they have some really nice resources right here on their website. So Stratasys is a manufacturer of 3D printers, and I want to go to, here's their 3D printers. I want to go to their FDM process. So FDM is called fused deposition modeling. So I'm going to go over there. And if we look, they have a number of printers here that they produce. We have one, it's kind of very similar to this F370, but it's not the most up-to-date type, but it's very similar to this in our fab lab. And what I wanted to do, I want the video. Hold on. Let me go back to 3D printers. Is it the resources? I apologize because I looked here earlier. Here's videos. There we go. That's what I was looking for. I didn't see it earlier. So I just want the video on. How come when I looked earlier, it was just so much easier? I know exactly what I want to look at. FDM technology. I did it on my other, here it is. This is the one I want. So I'm going to show this video, and this gives you an idea of what the technology for 3D printing that we have here on campus. So I am going to click on this video. We're going to play the video.
Fused deposition model is a 3D printing method that makes durable objects out of the same plastics used in everyday products. The 3D printer takes a spool of plastic filament, mounts it, and extrudes it onto a tray to build a part layer by layer from the bottom up. FDM materials are all industrial grade thermoplastics. That's what makes the resulting parts so tough. And it's also why FDM is changing the way industries design and manufacture. With FDM, a designer can sketch an idea and test it the same day. Industries can cut lead times and costs. Products turn out better and get to market faster. FDM parts are helping to build the cars you drive. They're in the airplanes you fly in. They're in the medical devices that save lives. FDM is cutting waste in manufacturing. It's helping engineers power remote villages in Africa. It's helping farmers feed an ever-expanding population. And the ideas keep coming.
So what I'm going to do is I'm going to replay the portion of the video that was the very start. And I just want to kind of show you that process one more time. I think it's like right about here.
The 3D printing method that makes durable objects out of the same plastics you see in everyday products. With FDM, the 3D printer.
This is the process.
Mounts it and extrudes it onto a tray to build a part layer by layer from the bottom up.
So that's essentially what we are going to be doing on the 3D printers that we have. So that filament is like, I like to think of it as, I call it weed whacker string. Okay. So the string that you would put in your weed whacker, that's very similar to what we have on a spool. And it's solid. And then it's going to go through a head. This head is heated. And then as it comes through here, it's going to lay down that plastic layer by layer. And then what happens is you kind of saw it in this video where the bed actually is going to move. But in our case, our head moves. So this bed moved, up and down as opposed to the head moving. In our case, our head moves up and down, left and right, in and out. Okay. So our bed stays in the same place. But what ends up happening is it needs to know layer by layer where the plastic needs to actually be laid down. And that's what our solid model is going to be kind of telling the software to do. Okay. So questions about FDM technology, fused deposition modeling is what it's called. And like I said, it's like that weed whacker string being melted and laid down wherever it tells it. Okay. It's very similar to like a inkjet printer. When you send a file to an inkjet printer, it tells the ink where it needs to go on the paper. That's kind of like what's happening here for a 3D printer. We're going to be telling the printer where to lay down the actual plastic, the molten plastic. Now, when he talks about using the different materials, so materials like ABS plastic can be melted through that head and laid down. So you can be making parts that would actually be in their final form and used out in industry. You can also use what we use up in our lab, especially for prototyping, is called PLA. It's a little bit less strong, tough type of a plastic, but it's great for prototyping and just testing out ideas. And that's the beauty of 3D printing. Its first uses were exactly that. Let's try to get a prototype before we start cutting metal to actually make the pieces. Okay. So that was its first intent, but because they've gotten so good, because they've gotten faster and faster, because they've been able to use materials that are like end product quality, now many parts that are 3D printed, if it's not in really large quantities, are going to be the final parts that are actually created. Okay. So they have been seeing a lot of different uses. Additionally, not only plastics, but it's pretty much anything that you can get into a molten form. So there are metal 3D printers out there. Okay. You've probably seen 3D printers that print food like pancake batter, and then it bakes it, and then it makes something, by layering it. There are houses where concrete is laid down layer by layer to create like the foundation or even more. So anything that you can get in that molten state that then can harden before the next layer is put onto it is a candidate for material in a 3D printer. Okay, so kind of interesting. So I'm gonna go back over here. So again, we're going to be creating a model. Everything starts with the 3D model, and that's where your SolidWorks skills now have now are going to allow you to create a 3D part. You can't do this with a 2D sketch. You cannot do this with like 2D AutoCAD. You can't create, you know, anything in a 3D model space. It has to be in a parametric model like we've been using. Now, there are different softwares that you can create this out of. Like, for instance, if you wanted to, they call it open source types of 3D CAD software. And those would be some levels of Fusion 360, which is an Autodesk product. That is a 3D parametric, like online cloud-based 3D parametric software. We don't teach it here at WCTC because it's not used out in industry very much at all. There's just kind of issues usually with proprietary when you're having to use software that's located on the internet. All right. So companies still have a little bit of a problem with that. So they like to buy their software. That's why we use SolidWorks, Creo, and such here at WCTC. There are versions of SolidWorks that you could buy personally. So if you wanted to take this to the next level and you wanted to do some modeling and create some 3D parts, you cannot use your 3D or your SolidWorks student version to make parts for something, for instance, that you wanted to maybe prototype to make money at a later date. Okay. You can only use the software that you downloaded right now for educational purposes, like for our classroom to learn SolidWorks. Okay. Now, if you were printing a part that you weren't planning on making any money off of in the future or prototyping for something, then using this educational software is totally fine. And that's the intent of this exercise. Okay. So always keep that in mind. You don't want to cross that line because you could get in trouble. If you wanted to, I just want to let you know that you can buy a maker version of SolidWorks at a deep discount that will then allow you to have that functionality, okay, for it. But it doesn't have the full-blown version like we do for the industrial, you know, type like side of things, like the CNC or the simulation and things like that. Although we haven't touched those things in this course, those are, you know, add-ons that are there. So just kind of as a side note. So what I want to do right now is I want to build kind of a simple part for you. I'm going to demonstrate a part, and I want to get to the point where we create that model in SolidWorks. And I want to show you how you then convert it to an STL file. And then I'm going to demonstrate the software that I'll be what we call slicing it in so that we can send it to the 3D printer. Okay. So I'm going to go out to SolidWorks here. Now, this can become your own design. All right. You do not need to. The intent of this demonstration is not to show you a part that you're going to copy. And that's why I don't have anything out there as a guide or anything for you to do. I just have the 3x3x3, and now you get to, with your imagination, your creativity, design something that you want to print out. Okay. So I'm going to make mine very simple. So I'm going to start by creating a new part, and I am going to pull in, we want to use our ANSI inch, because remember, we're using a 3x3x3 cube that we got to fit our part into. So I'm going to do ANSI inch. So it's kind of like the standard one that we've been using most often here for our models. Just was verifying. All right. And all I'm going to do is I'm going to do a pretty simple extrude. Oh, actually, I'm going to do a revolve. I'm going to make a just kind of a chess piece. That's what I'm going to make. All right. So I'm going to do a revolve boss base. I'm going to go to my front view for this case, and I'm going to start, as we always do with the revolve, with a center line attached vertically to our origin. Okay. And then this is going to be the center line that I'm going to do a revolve around. You don't have to do a revolve. All right. I'm just going to make kind of a simplified chess piece here. So then what I'm going to do is I'm going to now draw on one side here. And that's going to be the form that I'm going to revolve. So I'm going to start with a line, and then maybe draw a little bit of a base here at the bottom that it's going to sit on. Okay. And I'm going to stop there. And then I'm going to do the same at the top here. I'm just going to kind of go out something like, maybe like this. There we go. And then I'm going to add some curvatures here. Now, one function that we haven't used, I don't think in this class, is a spline. So if you want to make something, you know, kind of funky, or that it's not just a straight line, you want to be a little bit more free form, there is the spline command right here. I just left clicked on it. I'm going to start at my end point, and I'm going to just start, you know, kind of putting points in place here. And I don't know, I'll kind of do that. All right. And I kind of placed my points. And then once I'm done, I'm going to hit the escape key. And the last point is going to be what I have attached there. All right. That's it. And then what I'm going to do is I need to close this, because what I'm going to do is I'm going to revolve it around that center line. And I want it to be a solid piece at this time. Okay. Now, this is not fully defined, right? So I'm going to need to do that. Now, remember, your requirements were that it has to be inside of a 3 by 3 by 3 cube. Okay. So I'm going to add a smart dimension so that my overall height is about 3 inches. I'm going to say 2.75. That's about where I am right now. So as long as I'm less than or at the max 3 by 3 by 3. And then I'm going to do this guy right here. I'm going to say 1.5 at the top here. I'm just using the numbers that are here, and I'm kind of going close. This is going to be 1 inch. Okay. And then you'll notice that I have the rest of the blue section here. All right. To kind of make this a little bit easier, I don't want to have to dimension all this stuff. So I'm going to let SolidWorks finish this up for me. So I'm going to go to underneath my display or delete relations. There's that fully defined sketch. I'm going to click on that. And I have the outsides already defined for me. And I just wanted to calculate where those things are. Now you'll notice that it gave coordinates, if you would, for each one of the points along my spline. All right. And now at the bottom here, I'm fully defined. Okay. So I'm going to hit OK. All right. So now that I'm fully defined, I can exit my sketch, and I am going to then perform the revolve. And now you'll notice that here is my part revolve. So it picked that center line, that first line that I put in there, and it revolved it 360 degrees around. So I'm going to say, okay. So here it is as a final part. Okay. Now, if I wanted to add any additional, stuff to this, I certainly could. You could add, something at the top. If you wanted to make this tall, well, you can't make it taller or taller. And you wanted to maybe, for instance, maybe you wanted to kind of make it look more like a chess piece, like a rook at the top. You could do an extrude cut, and I'm going to do it on my front plane. Okay. And I'm going to add a rectangle right about here to here. And I'm going to dimension one side of that rectangle from my origin to be on the left-hand side. So maybe 0.2. And then I'm going to do from here to here, 0.4. So half and half. And then I'm going to say from the bottom, to my origin, because remember, it always needs to know in space where you're at in terms of your origin. 2.5. And then I'm going to make this 0.5. All right. So now what I have is I have a rectangle that I sketched on that center plane, and I'm going to exit here. And I am now going to do a mid-plane extrude. And I want this to be a total of, I'm just going to say 3 inches, just so that it goes far enough in either direction past. So now I've got to cut out in this direction, and I'm going to do the same thing in the opposite direction. So I'm going to do another extrude cut. I have to try to remember my, I think it's going to be the right plane I'm going to go on this time. And then now I'm going to do that same thing where I'm going to have a rectangle. I think I'm going to remember them. And I'm going to be 0.2 on one side. And I'm going to be 0.4 wide. Okay. And then from the bottom to my origin, 2.5. And the height, it has it as a square. Good. I'll just leave it like that. So then we're good. And then I'm going to do an exit. I'm fully defined. And it's going to remember mid-plane in 3 inches. That's perfect. And then now you're going to notice that now it looks more like a rook at the top. Okay. So you can kind of customize this as you wish. Okay. Now, Another thing that I'm gonna do, and I'll show you guys this because this is another command that we didn't do for, for anything that we've done. You'll notice that I'm not gonna worry about renaming these. This is kind of for your purposes only. I'm not anticipating that we're going to be, changing this or sending it for production. So if you want to change your names here, feel free to do that. Otherwise, you can leave them as the standards. I'm not going to be looking at your model, so you don't have to show me fully defined, but it's going to perform better and the STL file will work if you have everything fully defined. The other thing that I want to do is maybe I don't want to make this a complete, solid part, because right now it's a solid model. Maybe what I want to do is on the inside, I want to hollow that out. So I could create what we call a shell. So I'm going to do the shell command. And you're going to notice that over on the left-hand side here, there's this dimension. That dimension is for the wall thickness of 0.1 of an inch. Okay, I'm going to leave that. That sounds pretty decent. And all I need to do is I'm going to grab the bottom of my part and I'm going to say, okay. And what's going to happen here is it's going to hollow it out until it sees a top. Now it's not going to go all the way through here because it went up to that point and it made it 0.1, but you can see how it hollowed my part out. Now for 3D modeling purposes, this is totally a personal choice of yours. You can either hollow it out, doesn't take as long to model, or you can keep it completely solid. I'll leave that up to you. Okay. Now let's say you're like, I'd kind of like to maybe add my name to this. Okay. So, so to do that, you can go into the sketch mode and I'm going to click right here. Now you might have a larger area. I just want to show you how you can put text on and you can model it into your part. So here you're going to notice I'm going to go on this plane right here and I'm going to say sketch. And now I'm looking straight at it. So I want to draw on this plane right here. And we haven't used this command either, but in sketch mode, you're going to notice that there is text that we can add. Okay. So I'm going to click on the text and it's going to say, where is there a curve? So I actually have to have a line in place. I forgot that. So let me just hit escape here because it wants to know where to put the text. So I'm going to add a center line and I'm just going to make it horizontal. So it just needs to follow a line. That's it. So I'm going to go back. I'm going to do my text. I'm going to select that line where it says curve there. All right. And now I'm just going to click inside of this window where the text is, and I'm going to add my name, Kelly. That's it. You can keep going. You can hit enter. You can go to the next line and you can do a ribba. You can keep going and, put whatever you want on here. But it's only going to go in that one area that you had. So if you want this to be larger, so let's say you want to make a keychain and you want to put your, name in it or something or whatever, you just want to make sure that it's large enough to accommodate. So I'm not going to do my next line here and I'm not even going to do ribbon. I'm just going to do Kelly. Okay. Now, right now, if you want to change the way that font looks, you can do a couple things. Number one, you need to uncheck use the document font. Okay. Because that was set by our document settings. I'm going to uncheck that. What that allows me to do now is it allows me to change the font from what it's at. I'm going to click on font and now I have available to me kind of, that whole host of Microsoft fonts that are out here. So if you want to change this, you can. You can also do italics, you can do bold, you can do whatever it might be. So I'm going to do bold italics and then it's going to change my text to do whatever that is. So that's kind of like standard text editing mode type of thing. Okay. So remember, I'm in sketch mode. So it's sketching this on that surface. Okay. And the only thing that the line was there for, and again, use a center line is just so that it knows like where it's going to be placing it. Okay. All right. And then you can, click on the justify here. You can rotate it. You can, do a whole bunch of things, play around with it. It's kind of fun. So I'm just going to do okay. And you'll notice that I have my text here. So now all that I need to do is I'm going to do exit. I am going to select that sketch. And now I'm going to go to feature and I can either extrude it or I can cut it. So I'm going to do an extrude to start. And now you're going to notice that it's going to want to add material above the surface when I do an extrude, okay, an extrude boss base. So instead of 3-inch blind, I'm going to say 0.1, okay? And if I do that, I'm going to hit okay. Now what I have on that surface is I've got my name, my letters raised up above, okay? Now I'm going to do an undo on that, okay? And I'm going to reselect that sketch, or I can do an extrude cut. So if I do an extrude cut, now it's going to go down into the material. I'm going to leave it at 0.1, just blind 0.1, okay? And now what it did was it cut it into, can you kind of see how it went down into the material? All right. So this is only a demonstration of a couple little things, including maybe a couple things that we haven't done. So using that rotate, if you wanted to, the rotate function, if you wanted to create a chess PC looking thing, adding some text, or if you wanted to hollow out, I wanted to show you how you can use that shell command and then specifying that wall thickness. Okay. So let's say, and again, you can do whatever you want here. Get creative, 3x3x3 box, all right, that you can use, and then make what you want. Like I said, you can make a keychain, you can put lettering on it if you want to. I'll let you decide. I don't want to dictate this assignment. I want you to use your creativity. Okay, so once you have your model where you want it to be, I'm just going to do a file, save as, and I'm just saving it as my normal part file. So I'll call this 3D parts. Okay, and I've got it. I'm going to put it in just the regular. Yeah, there we go. Okay, my 3D part. This is just a part model at this time. I need to save it as an STL so that then I can pull it into what we call the slicing software. I'll explain that in a little bit, but the slicing software does not read a SolidWorks PDF or SolidWorks part model, okay, file. It has to be in what we call STL. And that's standard across like all 3D prints. If you go out on the internet, there is there's a couple of different sites that I think are good. Thingiverse is one, Printables is another, and you can download STL files. Sometimes they're free, sometimes they're that you have to purchase it, you know, for a couple bucks. But then you have that STL file that now you can send to a 3D printer. Okay. All right. So I've got my part and I want to convert it to an STL file. So I'm going to do a file, save as. And this is where down at the bottom here, it's remembering that I called it 3D part. And it's remember the last time that I saved it, it was as a SolidWorks part file. I am going to arrow down and you want to find the STL file and it's down here towards the bottom, STL. So it's a .stl and really that's just the file extension. And we're going to click that. Okay. And then we're going to click save and that's it. It's really that easy. Now you're going to notice that it added all these triangles to it. And that's what the STL file does. It triangulates it. And what that does is it sets the facet size for the actual part itself. Okay. So we're going to say okay or yes to that. And this saved it in the same place where your part file is saved. Okay. So if I go to that directory where I just saved this in, which was mechanical design or machinist. So right here, you're going to notice I've got my 3D part as the SolidWorks part file and the 3D part as the STL file. Okay, standard tessellation language STL is first. It was invented for stereolithography parts, which were the first 3D printed parts. Okay, so it's that easy to get it into a form that you can 3D print it. So if you are working on a software like Fusion 360 or Onshape, which are cloud-based free versions of CAD software, as long as you can get your model to an STL format, you're golden. Okay, and then you can 3D print. Okay, so I've got it in an STL format. All right, what I'm going to do now is I am going to slice it. So as we saw earlier, when the 3D printer creates this part, it creates it layer by layer by layer. So right now, this STL file took my solid model, it put it in this STL format. It's still a solid model, but we saw those triangles. Now what we need to do is we need to assign what's going on each one of those layers. And that's where we need what we call a slicer. We're going to slice this model up now into its individual layers so that it can write the G code. Yes, G code. You guys are familiar with G code, to let it know exactly where we're going to be placing the material. Okay. So the software that we use, and this is not on your computers here, I will have to slice this, but I'm going to show you the process of slicing, is going to be what we call Creality Print. This is going to be specific to the printer that we're sending it to. Okay. So I'm going to double click on Creality Print because we have Ender Creality 3D printers. Then we use this software. And what we're going to do is right now it says, I can just say, okay. The last time I was in here, I have an owl that I was looking at. I'm just going to do a file close. Do you want to save the project? No, thanks. Oh, I closed it. I thought I was closing the file. Hold on. Sorry. Go back in. It's just remembering the last file that I had up there. So we're in prepare mode. And all we're going to do is we're going to go up to file and we're going to open file. So now you're going to navigate to where you saved your STL file, not the SolidWorks part model file. Okay, it has to be the STL. So I'm going to go to where I saved it, which was in my SolidWorks for Machinists, and it's right here, 3D part. Okay, and I'm going to click on that, left click it, and I'm going to say open. Okay, and now what happened is we drew it at 3 by 3 by 3 by 3, and the units that are in here are in millimeters. Okay, so all I have to do is I just need to, this is the placement, I need to scale this. So instead of it being 3 millimeters, I want it to be 3 inches. So to do that, I am going to multiply 3 times 25.4, and that comes out to be about 76. So I'm actually gonna save or do this to 75. Okay, now it got a lot bigger. Okay, so I'm going to go out here, and you're going to notice also that it has it on its side. So we want to reorient the part. So I'm going to rotate this part so that it's standing upright. Okay, so if I go here, I think it's this one. I'm going to stand this upright so that I'm right about there. But I want this to be, see what's 0. I want it to be, I think 90 degrees. And this is what me playing with this does. Okay. So here's my part now standing on the bed. So this gray part right here is the bed, and I have it right in the middle of my bed. And you're going to notice that it's now standing up. Okay. So that's the part that I'm going to do. I'm going to be slicing it, pulling it in. That's why I need your STL file. I'm going to pull it onto our bed. And then I'm going to send it as a print when we have, for instance, multiples on here. What I'm hoping to do is to print 2 to 3 at a time. That way I can have one machine set up and then go to the next one and so on. So once I have that set up and I'm like, yeah, that's exactly where I want it to go. I can say down here, there's a button that says slice. Okay. So I'm going to click slice. All right, and now it's doing the work. It's creating that G code. And now it's sliced it for me. So if I want to see what it's going to do, you'll notice that I have this layer here. There's going to be 688 layers in my 3-inch part. Okay. And what I'm going to do is I can actually left click this and drag this down. And you're going to notice that I can see each one of these layers forming layer by layer. Okay. Layer by layer. All right. I can also, at any one of these layers, I can also look at what is the step that it's taking, with the actual nozzle itself, like how it's building that individual layer. Or I can move it to another layer and I can do the same thing there. I can look at, okay, how is it actually making that layer? All right. So here's my preview. Then what I can do is I can export this. I want to take this G-code file now and I want to say, okay, this looks good. And I want to export it to a jump drive, for instance, that I can then take it to my 3D printer and I can then have it printed. So the process that we go through is going to be from our SolidWorks part to an STL. From the STL, I'm going to slice it so that I can see what each layer is going to do. This program writes the G code for each one of those. And then now this is the file, the G code file that I'm going to use on my 3D printer. Okay. This makes the G code for us. It's very simple. Yeah. And this is actually free software that you can download on a personal computer. We don't have them on the computers in this lab. It actually, yes and no. So it is gonna, when I, for instance, let me go back to prepare. You're gonna notice right here, the printer here is the CR10. That is the printer that we have upstairs in our mechanical design lab. But there are other ones that I can pick, okay, that it will write it for. But yes, you have to set up your printer for it. There are multiples like that you can do. So you just have to be sure that whatever slicer you choose, and there are other slicers out there in the world, that it will create the G code for the machine you want to send it to. And that's this one. Okay. So that's the process. So what I need from you, because I'll be doing this part, like putting them on the platen and then sending them to our printer, what I need you to do is create that part file and the STL. Now, this evening, if you're ready to start doing that and you send me those files, what I'll do is I'll start putting them on a platen. And then at some point I'll go upstairs, and if anybody wants to come along with me, you can come up to the lab and see them running. I will be running parts for sure on Thursday though, as well. Okay. So if you end up not sticking around, or if you wanted to come on Thursday to watch that process or get your parts, then, you can come at that time as well. Thursday is going to be work time only, whether that is 3D printing or if it's working on anything that you need to catch up on. And then I'll be printing parts that evening. So any questions right now? So from this point, like on the slicer to the 3D printer, I'll take care of that, but you certainly can be part of that process and watch me, put it on the machines and such. Okay. All right. Questions? I'm just kind of looking at our chat box. I don't see anything in there right now. So what I'm going to do is I'm going to stop our recording.